Hello everyone, welcome back to the channel. Today, we're diving into the basics of welding processes. In part 1 of Introduction to Welding Engineering, we scratched the surface. Now it's time to go way deeper. Welding isn't just melting metal. What you do before and around the arc is what makes or breaks the weld. Let me show you why. Let's break it down. What is a welding process? A welding process involves using special equipment and techniques to permanently join materials, usually metals. Depending on how the weld is made, welding processes can be classified in two main ways. 1. Fusion welding processes. In fusion welding, the material is melted and mixed, then re-solidified to form the weld. This includes most common welding types like MIG, TIG, and even resistance welding. 2. Solid phase, state welding processes. Here, welding happens in the plastic or soft condition without fully melting the materials. Think of processes like friction welding or ultrasonic welding. So, what are the key ingredients to make a strong, reliable weld, especially in fusion welding? Let's look at this simple and powerful diagram. At the center, we have, to make sound welds, we need, and branching out from that are the four main requirements. 1. Heating. You need proper heat input to cause melting of base metals and filler metals. Too much or too little heat can weaken the weld. 2. Protection. Protect the molten weld pool from contamination. This is often done using shielding gases or flux to prevent oxidation and to protect the weld zone from ingress of gases such as hydrogen oxygen. 3. Cleaning. Clean surfaces mean better welds. Remove rust, oil, paint, or any dirt before welding. 4. Adequate properties. Finally, the weld should match or exceed the mechanical properties of the original metal. Adding alloying elements to the weld, to produce the desired mechanical properties. So, whether you're a beginner or brushing up your welding knowledge, remember, heating, protection, cleaning, and adequate properties are your golden rules for making sound welds. Explaining further, I will start with protection of the heat source and weld area from oxidation. In MMA welding, the gas shield is produced from the combustion of compounds in the electrode coating. The gas produced is mainly carbon dioxide, but electrodes are available that produce varying amounts of hydrogen gas, which gives higher levels of penetration. In submerged arc welding, the gas shield is again produced from the combustion of compounds, but these compounds are supplied in a granulated flux, which is supplied separately to the wire. MMA electrodes or SAW fluxes containing high levels of basic calcium compounds are used where either hydrogen control, or high toughness and strength has been specified, as most basic agents have a very good cleaning effect. In MIG, MAG, TIG welding, the gas is supplied directly from a cylinder, or bulk feed system, and may be stored in a gaseous or liquid state. In TIG MIG welding we generally use the inert gases argon or helium. In MAG welding we generally use carbon dioxide or mixtures of carbon dioxide or O and argon. Secondly, cleaning of surface contaminants, refinement of weld metal. The cleaning, refining and deoxidation of the weld metal is a major requirement of all common fusion welding processes. As a weld can be considered as a casting, it is possible to use low-quality wires in some processes and yet produce high-quality weld metal by adding cleaning agents to the flux. This is especially true in MMA welding, where many cleaning agents and deoxidants may be added directly to the electrode coating. Deoxidants and cleaning agents are also generally added to FCAW SAW fluxes. For MIG, MAG, TIG welding wires, deoxidants, such as silicon, aluminum and I-manganese must be added to the wire during initial casting. Electrodes and wires for MIG-TIG welding must also be refined to the highest quality prior to casting, as they have no flux to add cleaning agents to the solidifying weld metal. Thirdly, properties of sufficient values, produced through alloying. As with deoxidants, we may add alloying elements to the weld metal via a flux in some processes to produce the desired weld metal properties. It is the main reason why there is a wide range of consumables for the MMA process. The chemical composition of the deposited weld metal can be changed easily during manufacture of the flux coating. This also increases the electrode efficiency. Electrodes of greater than 160% are not uncommon for surfacing applications. In SAW, compounds such as ferromanganese are added to agglomerated fluxes. It is much cheaper to add alloying elements to the weld via the flux as an ore or compound. As with the cleaning requirement described above, wires for MIG, MAG, TIG must be drawn as cast, Thus all the elements required in the deposited weld metal composition must be within the cast and drawn wire, and is the main reason why the range of these consumables is very limited. With the developments of flux-core wires, the range of consumables for FCAW is now more extensive, as alloying elements may be easily added to the flux core in the same way as MMA electrodes fluxes. Finally, heating sufficiently high for the type of welding being done. There are many heat sources used for welding. In fusion welding, the main requirement of any fusion welding process is that the heat source must be of sufficient temperature to melt the materials being welded. The intensity of this heat is also a major factor, which will mainly affect the speed of the welding operation. This section briefly describes some of the various types of fusion and solid phase welding processes available to the welding engineer. Don't forget to like, subscribe, and hit that bell icon for more welding tips and engineering content.